WMPG thrives with support from listeners and from Maine Solar Solutions. Maine Solar Solutions, helping empower homeowners and businesses with solar electric solutions for 9 years. Information at mainsolarsolutions.com.
You're listening to WMPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me, as always, is Bernie Rhyme, DJ Star Watcher. How are you, Bernie?
Yes, hi, Sarah. Very good, thank you.
Bernie's our professor of the Astronomy Lab here at USM and our local protector of the night skies. Reach out to us at WMPGScientificallySpeaking@gmail.com or on Twitter at WMPGSciSpeak. And you can head over to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Welcome to another episode of Scientifically Speaking here on this lovely Friday. We are joined today by, again, our very esteemed guest, former host and producer of Radio Astronomy, Director of Communications at Blue Shift, NASA Space Ambassador, and what was the last thing?
Aerospace Education Officer for Brunswick 021. It's Civil Air Patrol. It's a composite squadron. It's
right. It's
cool.
Seth Lockman, welcome back to the show.
Thank you so much, Sarah. And may I just say, I got so excited when you said it was Friday. And then I realized at time of recording, it is Wednesday.
You just gained 2 days, Seth. But you lost 2 days, either way.
I did both, Bernie. It was a roller coaster. Okay.
Well, in some ways, you're kind of like you're time traveling by being on the show. So,
right.
You know.
It was amazing. Yeah. So the exact name for the volunteer thing is Solar System Ambassador. And I actually queried. I asked the headquarters. I said, "Am I an ambassador to the solar system or from the solar system?"
Oh, that's good.
And they've responded to every other email I've ever sent them.
They didn't take you seriously. It could be both. Obviously from, because you're here, but two also, because if you know something about them, you can communicate both ways, Seth.
You'd think, right? But no, I mean, I do know that I don't have diplomatic immunity.
Oh, that's too bad.
Yeah.
Maybe you do on another planet.
Oh, maybe.
Yeah.
Maybe.
Yeah.
You never know. You should keep that, if you have a badge or something, just keep that on your person.
If aliens ever land, that's the first question I'll ask them.
Yeah. Just flash it.
Yeah. Am I working for you or with you?
Yes, you. Oh.
So last episode, we took you as our listener through not very far in the solar system, but through halfway, not even halfway, through our sun and 3 planets of what it is like for there to be precipitation on those planets or the stars. And we stopped at our beautiful blue planet, and now we're just going to continue the journey. So before I leave our vicinity, though, anything on the moon that we need to talk about besides meteors and meteorites and
little bit. So it doesn't exactly rain on the moon, but it does kind of play into our water cycle here on Earth. So with enough energy through electrolysis or just good old solar radiation, right, you can take our precious dihydrogen monoxide and you can split it up into molecular hydrogen and just oxygen, right? And sometimes that oxygen combines with other oxygen and you get ozone. Sometimes it combines with more hydrogen and you get water again. And sometimes that oxygen just kind of flies off into space. And so when that happens, Earth actually develops a tail of oxygen, kind of like last episode, Bernie, you mentioned that Mercury has a tail of sodium.
Yeah.
Yeah. So Earth has a tail of oxygen. And so the moon kind of flies through this tail of oxygen, which is a byproduct of Earth's water cycle, right? And then that oxygen combines with metals on the moon's surface and it rusts, just like what happened to Mars. So it's a slower process for sure. The moon's not turning red anytime soon, except for those eclipses. But that's a different thing.
Yeah.
But the moon is rusting due to oxygen that's thrown off as a result of kind of when evaporation just kind of keeps going as this kind of weird part of our water cycle.
I don't know why I love that so much. We need to like send some like Rust-Oleum or something.
Yeah, we'll clean it up.
All right,
Wow.
Artemis generation, fix this.
That's super cool though. I never knew
Right?
that. Yeah.
Yeah.
Wow.
Yep.
And we have found like rust on the moon.
Yes.
That's excellent. That's just wow. You know how they say like if we didn't have oxygen, we would it's kind of counterintuitive. Like oxygen is, what's the word? You know how we have antioxidants
Like tomatoes
like
and garlic.
oxidizing us? No, like blueberries.
Oh
And
yeah.
it is causing us to get older. Like that is what makes us get older, but at the same time it is what we need to live.
Yeah, because it the oxygen like gets into the DNA and causes all kinds of problems
Right.
with multiplication. Yeah.
Right. Yeah.
Yeah.
I forgot where I was going with that. Anyways, all right, let's move on to Mars, the actual red planet.
Yeah.
One of you said there's water on Mars.
Yes.
I mean,
Seth,
sometimes when it gets
yeah.
warm enough, there could be a little bit of water just for like a few days. Yeah.
yeah.
Where?
Basically along the equator, there are these frozen lakes. They're underground. They're like aquifers, right? But the water freezes, and then in the Martian summer, which has a little bit to do with the inclination of its axis, but mostly has to do with how close it is to the sun, because it's kind of got a more eccentric orbit than Earth does. So when it's kind of closer to the sun, along the equator, this water, which is incredibly salty, so like if you think the Dead Sea is salty, right? Like this is more. And so because of that, it's able to exist for a short time in the incredibly low pressure of Mars's atmosphere, which is like what 0.5% of what we have here on Earth, right?
Yeah.
About 1%.
And so, so it gets warm enough that this water melts, and then it'll kind of cascade down the side of craters that are, on or near the equator. And this has been observed, at this point, thousands of times by the Mars Reconnaissance Orbiter, I think ESA's Orbiter 2. And so at this point, it's pretty well established that in the summer, for like a week or two, you can have this like slope lineae, these kind of little creeks running down the sides of.
But wait, the water is underground.
Yeah. So then once it melts, it kind of busts out of this subterranean lake and will kind of flow down in these crater walls where it then freezes and sublimates or just boils off.
Gotcha.
Yeah, you can't go swimming on Mars, but it's kind of coming through as it goes down the landslide. Yeah.
Oh.
Yeah.
So similarly, NASA's Mars Reconnaissance Orbiter also, this was back in 2012, found that there's snowfall on the poles of carbon dioxide. So that's the other kind of precipitate. Well, I guess the water wasn't precipitating. It was just becoming liquid. This is like the carbon dioxide is actually falling.
Oh, okay. So that would be a deposition where it goes from a gas just straight to a solid, and then just falls out of the sky as a powder.
Yeah. Snowfalls of carbon dioxide. Isn't that cool?
That
Dry
is.
ice. Yep.
Yeah. But
Now,
it's only over the South Polar Cap, apparently.
Right. The North Polar Cap is water ice. The South Polar Cap is dry ice or CO2.
Oh, I didn't know that.
Oh, yeah.
Wow.
Interesting.
Yeah.
It,
So yeah.
I was just gonna say it, dry ice needs to be at about minus almost 200 degrees Fahrenheit. So I guess that's probably, I don't know if there's a difference in temperature at the two poles, but yeah.
Yeah.
Yeah, I'm not sure the exact temperature.
Snow's carbon dioxide.
I know that when I was at that school up in Limestone, my dad would call me to mock me on the days when it was colder in Limestone than it was on Mars.
Yeah, right. That happens.
And I told him, that's not fair, Dad. It's the Martian summer. These are temperatures from the equator. Next year, you won't be calling me so much. And then he wasn't, because it was Martian winter. But yeah, we do know Mars does have water clouds, right? Coming off of that northern ice cap, the water, it doesn't evaporate. It just straight up sublimates, goes up into the upper atmosphere, and it does produce clouds, and then it deposits frost pretty much across the planet, though mostly in the northern hemisphere. And
but it doesn't snow? It just...
I guess kind of. I mean, it certainly wouldn't be snow like we experience it here, because it would be so diffuse.
Yeah.
So yeah, no, I don't think it's like, Jingle Bells and any of that. But the United Arab Emirates sent their probe, the Hope probe, or Al Amal, I think, and it has two instruments on board that are specifically about detecting. Well, one of them is just totally about detecting water ice in clouds, and then there's another one that's kind of among the things that it can detect. And so part of their mission is to try and get better predictive models, so that they can, have weather forecasts on Mars and see, when are there going to be dust storms, but also where are the water clouds or the water ice clouds. Yeah.
Very cool.
Yeah.
I wonder what it would be like to, have a snowflake kind of just fall on your tongue.
On Mars? Well, your tongue would be boiling, but then the snowflake would be nice, I guess.
Yeah, right. It's only 1% of the atmosphere, so you're not going to have a snowflake. There's no atmosphere to make the snowflake, really. Yeah.
I don't know what we know that there's water ice in the clouds. We know it comes down.
Yeah.
But I don't know what the crystallization is like. That must be I know there are people that photograph snowflakes. So I hope that a couple of them signed up for that trip to Mars.
Wow, what if they just look different? What if they're not hexagonal?
That could be.
I mean, that's mostly because of the hydrogen bonding, right? I mean, the same rules should apply regardless of the temperatures or pressures, right?
That's fair.
For gravity.
Yeah. Maybe.
I don't know.
Yeah, we did a show in snowflakes, remember, Sarah?
We did, yeah. And here they're always hexagonal.
Right?
But they're always,
Well,
there also could be columns.
There's different ones where they could be columns, or they're flat. But that's they're still hexagonal.
Right.
That's hexagonal.
Yeah.
Okay, well, I'm gonna go. $5 says that they're hexagonal on Mars. That there are snowflakes and they're hexagonal.
Okay, when we find out in 10 years,
let's see what happens.
I wonder what carbon dioxide snowflakes.
That's right.
Oh, now there's a question.
That could be different carbon. Yeah,
that could be a different shape.
Totally different.
I don't know. Yeah.
All right. Anyways, moving on. Jupiter.
Oh, actually, don't you want to cover Europa, a moon of? Oh, that's the moon of Jupiter. Okay, we'll find. The moons of Mars, they're not going to have any hydrological cycles. We can skip them.
No.
All right, we'll go into Jupiter then.
So Jupiter may rain helium.
Mm-hmm.
This is actually very recent. Yeah. I'm a little delayed there, but okay. This is actually very recent. It was not until May of this year did they experimentally prove this. So not observationally, but they did an experiment to test a hypothesis from nearly 40 years ago. And basically scientists have never been able to achieve the conditions in an experiment that mimic what we see on Jupiter.
Right, because helium is finicky as all get out when it's in a liquid form, right? That's got to be really tricky. There's got to be just a thin layer of the atmosphere where that happens, right?
Yep. So the paper in question, not in question, that we're referencing is evidence of hydrogen helium immiscibility at Jupiter interior conditions. And it was done by an international team of researchers. And what they found is that there is helium rain, which shows as helium droplets that fall through liquid metallic hydrogen, very similar to how like water raindrops fall in our planet, on our planet. And it is possible over a range of pressure and temperature conditions that are kind of similar to what you would see on Jupiter and Saturn.
Wow.
The key thing here is that hydrogen and helium make up the bulk of Jupiter's atmospheres, but they don't mix. And so, like deep within its atmosphere, Jupiter's atmosphere, these two separate, and helium then forms droplets that are denser than hydrogen, and they rain. So, anyways, it's still experimental, but really cool.
That is.
Yeah.
And as a gas giant with no solid surface, this rain would therefore be a virga. You would never touch the ground.
Never reach.
Yeah.
There's no surface to reach.
There's no ground. Yeah.
Yeah. Yeah. I mean, it would probably just be a cycle of phases.
Yeah.
Yeah. Imagine if you, I don't know. Like, imagine if you had to do that. Just like keep morphing as you fell through space.
This episode is spacey. I hope we have some like reverb on this episode.
Yeah. Actually, it may not even have a solid core. They're now thinking it might be a liquid metallic hydrogen core. There may be no solid anywhere in Jupiter.
That's crazy.
Yeah. So then all these other layers, all these other things happening with no solid core at all.
Yeah. All right. Bernie, take us to Europa.
Yes. So that is one of the 4 Galilean moons of Jupiter that you can see with just a pair of binoculars. And that has an ocean that has, under the surface, of course, way down there, more water than all the oceans on the Earth combined.
Oh.
Even though Europa is smaller than our own moon. Basically, there's a great poster where you can take the bubble of water that represents the oceans on Europa, and it's as big as the bubble of water that would represent all, or just a little bit bigger than the bubble that would represent all the oceans on the Earth as a sphere. It's about a third of the size of the U.S., and then the height would have to be, I'm not sure the height, but I've seen that poster, so that's a good visual way to see that. So of course the point is we have a mission going there called the Europa Clipper. It's going to be a while before it's all fully engineered and going, and obviously it's way below the surface, but it has these weird cracks and things that there's all kinds of possibilities of what it could be. And actually they found water under the other Galilean moons also. Callisto may have some of that, even Ganymede further down based on radar. And of course, Io, that's volcanic. That's a really neat place all by itself. Too hot there for liquid water, but yeah. So Seth, what else can you add to that?
Well, I've been fascinated by Europa for a while because it was, I was an Arthur C. Clarke reader as a kid and all that. And so I know or Europa has this ice shell. It's the only thing that could be that reflective. So it's got an ice shell, which we think is like 10 to 15 miles thick, and then the subsurface ocean is like, the maybe 40 to 100 miles deep, which is really deep.
Yeah.
By comparison, Challenger Deep is 11 miles down?
Yeah, about 11, 12 miles, yeah.
And here we're talking 40 is like the minimum depth, right? So this is like and this is a moon too. So this is a relatively small thing. So this is a big chunk of that planet, right? So I got to thinking, this is almost like Earth's, crust and mantle. And I got to thinking, okay, so you've got this water in Europa, which, maybe you could sustain life down there because there could be heat, there could be chemicals coming up from like hydrothermal vents, right? So it could functionally be similar to water here on Earth in terms of sustaining life, but in terms of it rising up to the surface, freezing, becoming part of the surface, and then eventually subducting, and then kind of melting again. That's more like lava or magma, right?
Yeah.
So I got to thinking, water is a part of Europa's rock cycle. Was there such a thing as a rock cycle? Turns out there is. The geologists, this isn't a radio show about geology, folks. Turns out the geologists already figured this out. There's this whole complex thing. So I went down the rabbit hole of what is the rock cycle. And yeah, basically water ice is like an igneous rock on Europa. That's like its role.
Yeah. And of course, Io is perfect for the rock cycle because it's being turned inside out every few thousand years because of the gravitational interactions. There's all liquid and solid rock happening all the time.
Poor Io.
Yeah.
So that's like a water, all the volcanic lava just is their water cycle, and it's the rock cycle.
Yeah, Europa, the gravitational needing on Europa is crazy. Like, I this is one of the like facts that I still think about from doing the show, that if you're standing on Europa's equator at low tide, because the surface just has a tide, right? And between high tide and low tide, you'd be more than 300 feet vertical difference.
Wow.
Oh, you mean Io?
High tide. Yeah, Io. Sorry, which one were we talking about?
Because of the gravitational force with Jupiter. Yeah, 300-foot tides. Yeah,
it's crazy.
Wow.
I remember doing that.
That's crazy.
Yeah, they probably don't even need elevators. If they can find some way to keep the building level and just have the ground rise up around it, they wouldn't need elevators.
Yeah, the earthquake buildings in Japan would be really facing a challenge in Io. Make them earthquake proof and tide proof and everything else proof.
Oh, that's crazy. But yeah, so anyway, on Europa, it doesn't rain, but there is water, but it's more like rocks here on Earth, including the liquid molten-y part of the rock that we don't usually think about in the rock cycle.
That's so fascinating.
Yeah. Okay, next planet.
So this next type of precipitation, if you will, is a theory found on Saturn, Neptune, Uranus, and possibly even Jupiter, but mostly like I see it with Neptune, Saturn, and it's that there potentially are diamonds that rain on these planets.
Yep.
It's a theory by scientists over at JPL. And what they think is happening is that Saturn has these really intense lightning storms. And Saturn has a lot of methane in its atmosphere. And the lightning storms cause the methane to break up. And as you know, methane is carbon and 4 hydrogens. And so it leaves these carbon atoms kind of freely floating. I guess the hydrogen are too. But specifically, we're looking at the carbon atoms because diamonds are made of carbon. And as the carbon atoms, these free agents, travel through the dense atmosphere, they get pressurized into tiny diamond pieces. And they're not big. So
this is kind of like how water or oxygen in our atmosphere will get you ozone. It's kind of similar.
Pretty much, yeah. And so what happens is they'll become these tiny, tiny little diamond pieces, but then once they get kind of closer to the center of Saturn, they basically get too hot and then they like decompose into like liquid carbon, I guess. But yeah, so they're temporarily, you could fly through in the atmosphere and just, with a net, capture all these diamonds.
Wow.
Again, it's just a theory, but that's how they think it works.
Okay, so there's two just mind-bending things going on here. First, you've got rain that's changing its state of matter as it goes down, which is actually no, water does that here on Earth.
Yeah, I was gonna say that's not that crazy.
Okay, so I wasn't thinking about it, but actually that's just what sleet is, right?
Yeah.
So, never mind. That's just normal.
That's just normal.
Yeah, but okay. So the other thing though is that on Mars we've talked about for sure, and Jupiter probably, and who knows what other craziness is going on out in the gas and ice giants. But there's multiple types of precipitation. Like we've got rain, we've got snow, That's
Hail.
pretty much it.
Hail, sleet.
Yeah.
Well, right, but it's all water, right?
Yeah.
Like it's not a totally different chemical like raining down on us, right?
Right.
Like you're usually going to get some form of water, but that's not a
Yes.
safe bet on every planet that it's only going to be like one thing.
Yep.
Crazy.
Okay.
Yeah. I guess we haven't really talked about. I mean, they think it could also rain diamonds on Jupiter.
Why not?
So, yeah, I guess you could have. Well, I mean, it would be different, probably different areas of the atmosphere.
I challenge Paul Simon, if you're listening, to write a song about this: diamonds raining on Jupiter.
Mm-hmm.
And before we move on from Saturn, I do want to briefly acknowledge Enceladus, moon of Saturn. It has a very similar situation to Europa, where gravitational kneading allows the water to exist in a solid state as ice on the surface and a liquid ocean underneath. So it's kind of more like Earth's rock cycle, but it is technically a water cycle. But also, this is kind of cool that Enceladus has a low enough gravity that it shoots its water just out, not even out of into its own orbit, just escape velocity for the moon, right? There will be geysers every once in a while, and water vapor ends up orbiting Saturn.
Wow.
Forming one of the rings, but it's kind of diffuse. It's not the most coherent ring. And so sometimes it'll fall down into Saturn. So it does rain water on Saturn because of a moon.
Oh yeah, it's a good connection to make. Yeah, that's
Ain't
right.
that nuts?
That is nuts.
Yeah.
Wow.
Yeah.
That's cool. It's like just we're all raining on our moons and planets.
Yeah.
Part of Earth's rain ends up on Earth's moon.
Right.
Enceladus is what would have become a volcanic ejecta or like a geyser plume going too fast, winds up raining on Saturn in a manner reminiscent of meteoric bombardment here on Earth, which, if you think about it on a 4.5 billion year time scale, is kind of
Yeah,
rain.
it's rain too.
Join us next week for part 3 of the rest of our journey through the solar system and beyond. You have been listening to Scientifically Speaking with myself, Bernie, and Seth. Stay tuned for Something for the Weekend with Anella. And from your favorite nerds, just a reminder to vaccinate to mitigate. And again, we are already congregating, but we can congregate more.